So at the start of the organic unit, I talked to you about two types of categories that organic molecules can fit in. We can either classify them as aliphatic or aromatic. Just to recap that information, an aliphatic compound is an organic compound that does not contain a substance called benzene. And an aromatic compound is an organic compound that does contain benzene. So in order to be able to classify organic compounds as aliphatic or aromatic, we need to know what is benzene. So let's take a look at benzene in a little bit more detail here. First of all, you need to know that benzene has a chemical formula of C6H6. And because of that, we can come up with what that structure looks like. And this is what we've come up with that structure to look like, is 6 carbons in a ring with each carbon having 1 hydrogen coming off of it. The problem with that is that just in that formation alone, each carbon doesn't have a full octet. And we know that carbon always has a full octet. So what was originally kind of thought was, okay, well, let's stick a double bond in an alternating location inside that ring so that each carbon ends up with a full octet, 4 bonds around each or attached to each carbon within that molecule. And that kind of was fine for a little while, and then as we kind of looked at it and looked at more details of this, we thought, okay, well, the double bond could be here, here, and here, or it could be here, here, and here. And I've drawn these stick diagrams for you to just kind of be able to see that a little bit more cleanly without the hydrogens in the way and all the letters and stuff. And you can see how those double bonds are in different spots within each molecule. Both of these would still be considered benzene in terms of the fact that there's C6H6 in their chemical formula. But we call them resonance structures. So a slightly different form of the same molecule that has the same name, different from isomers. Okay, so resonance is not really a word that you need to necessarily know for this course, but that's what these guys are called. Now, the other thing that's really interesting about benzene is that because we've kind of got these double bonds in here, we would think that if we were to present these molecules with hydrogen to react with, that this reaction would occur really quick, kind of like an addition reaction, and it would just be really, really fast. Turns out, though, that when we present benzene with hydrogen to react, it doesn't react. It's a very, very stable molecule as C6H6. With some further study on benzene as well, what we were able to find out is that the length of the bond in benzene is the same no matter where we're looking at it. And the reason why this was interesting to researchers at the time as they were studying it is that they knew that a carbon-carbon single bond had a length of 1.5 angstroms. And so that's just kind of written over there for you to be able to see that. And they also knew that a double bond had a length of about 1.3 angstroms, so it's a little bit shorter than a single bond. When they measured the lengths of the bonds of the benzene ring, they expected to get a length of a single bond here and a double bond there and a single bond, double bond, single bond, double bond. Turned out, though, that when they made their measurements, all the bonds in benzene were all the same length, and it was kind of an in-between hybrid length between a single and a double bond. And so the measurement that they came out with was actually 1.4 angstroms for the benzene ring. And so this was really interesting to them because they kind of said, okay, well, there's not really single or double bonds in here. It's a bit of a hybrid where these 6 electrons, 2, 4, 6, in these 3, what would maybe be considered the double bonds here, are actually being equally shared between all of the carbons simultaneously. And so it's kind of like there's sometimes here and here and here and here and here and here. And so as they kind of looked at it, they said, okay, well, maybe the best way to draw this molecule then is just a 6 carbon ring, and then just stick a circle in the middle to just kind of show, hey, this is all encompassing of the 2 different resonance structures that we have with this, and that these electrons are all sort of just being shared equally within the ring for all of those carbons that are part of that ring. And so this here is the diagram of a benzene molecule that you will see for the rest of the course. All right, so we're going to look at some naming of organic compounds that contain benzene, or aromatics. Now there's 2 kind of situations that you have to be aware of. The first is that benzene can be named as a branch in an organic compound. And when it's named as a branch, we use the name phenol, listed over here in quotations. And here's some examples of when that would occur. So if you've got benzene, a benzene ring coming off of a parent chain somewhere in the middle, it's really hard to make this the parent chain and these the branches coming off in two different directions. It just doesn't really work that way. And so if you've got a benzene ring in the middle of a parent chain, that benzene ring is going to be a branch, and we call it phenol. So we just number this chain using regular numbering rules for branches, and this ends up getting 3-phenylpentane as its name. This one right here, again, this has a double bond in the parent chain, so this has to get the numbering system, so that means this has to be a branch in order for this to occur. We don't have names of alkyl branches that have double bonds in them for this course, and so we're going to number this, giving the double bond the lowest number, so 1, 2, 3, 4. Phenol gets, the benzene ring gets a number 3, so we say 3-phenyl but1-ene. And then this one right here, same reason as before, this has to have the numbering system for the parent chain because it's got a double bond in it. And so 1, 2, 3, and this branch phenol, or the benzene branch phenol, ends up on carbon 3, so 3-phenylpropene. And so that's how we name compounds, organic compounds, with benzene as a branch. We use the word phenol. Now, benzene can also be a parent chain in other situations, and some examples of when that would be, for example, this one right here. We've got a benzene ring with just a methyl branch coming off. So then I would just name this methylbenzene. I don't need to give this a 1 because wherever I'm going to start the numbering, I'm going to start it so the branch gets the lowest number. So 1, it's always going to have a 1. If I had multiple branches here, then I would give it numbers, but I don't. So this is just methylbenzene, sometimes referred to as toluene. Now, one example where benzene is the parent chain, but we don't use the word benzene as the name for that parent chain, is this one right here. So this is the parent chain. We have a benzene ring, and then we just have a hydroxyl functional group branch that comes off. And the name that we actually give this is phenol. And this is different than phenol. Phenol, NYL, is when benzene is acting as a branch in an organic compound. Phenol is an alcohol, OL, if you remember our naming from the clip that we did on naming alcohols. And so this is an aromatic alcohol that we have, but it doesn't follow this rule where, yes, benzene is a parent chain, but we don't call it benzene in this case. That's the one exception that you'll see in this course. Some other things that you need to be aware of as it relates to naming benzene as the parent chain is sometimes we can get the benzene ring to have multiple branches on them. And when we have 2 branches, those branches can be in one of 3 configurations. We can have 1, 2, we can have 1, 3. So if I number this in this direction, 1, 2, or 1, 2, 3, or 1, 2, 3, 4. Those are the 3 configurations that I have. If I have this chlorine over here, well, then I would number it this way, and it would be the 1, 3 configuration again. And so we can name this as regular. We just go 1, 2 dichlorobenzene. That should make sense from our previous videos that we did naming of halides and now aromatics. We've got 1, 3 dichlorobenzene or 1, 4 dichlorobenzene. But what you also need to know is there's actually a second way that you can name these. And instead of using numbers, we have a prefix that we throw in front. And that prefix is for the 1, 2 orientation is ortho. So we say orthodichlorobenzene. If it's in the 1, 3 orientation, then we can say meta-dichlorobenzene. And if it's in the 1, 4 orientation, these branches, and these branches don't have to be halides, they could be alkyl branches like methyls or ethyls or whatever. If it's in the 1, 4 orientation, we can say para-dichlorobenzene in this case. And then you can also abbreviate this as well. So instead of writing out ortho, you can just write O-dichlorobenzene or M- or P- to represent the same thing. So you will see stuff like this. You will see questions on these types of things. So that's why I cover it here. And that's what you guys need to know about naming aromatics. Thanks for watching.